Okay, hello. Welcome to Are We Desktop Yet? I'll be talking a bunch of, interesting challenges and stories of writing a whole desktop environment in Rust. More specifically, as alluded to before, I'm going to talk to you about what Cosmic is. So I assume not everybody has heard of Cosmic. Maybe quickly raise your hand if you have before. Oh my, okay, that's more than I expected. Okay, so maybe let's continue the quiz a little bit. Who is here using like Linux in their day-to-day life to a substantial amount? Like daily or at least bi-daily or at work, whatever. Okay, who here from those people knows about the concept of a desktop environment? Who knows what desktop environment they're using? Okay, who knows of like smaller stuff like tiling window managers? Who has used something like i3 or Sway or Neri or, okay, cool. That's a good base. I'm still giving a little introduction to this topic because not everybody seems to be familiar with these terms. So what is Cosmic? This is Cosmic. Cosmic is a desktop environment. If you're coming from something like Windows or Mac OS, that is probably not a concept you know because Windows just has the one desktop you get when you log in, right? On Linux, that's quite different. You usually have your GNOME or your KDE as different environments, and now Cosmic is a new one. What makes it stand out? Why would you want to use Cosmic over the well-established ones? Well, it has a first-class tiling experience. I'm going to demo this a little bit later, so who are all of you who don't know what a tiling window manager is? That's one of the main selling features. It's very keyboard-driven, but you can do absolutely everything with the mouse. The idea is to really lower the bar of entry. You need to like learn how to use this properly, and it's very customizable and personalizable. So you don't know how something looks or something behaves. There's a good chance you'll find a setting or switch to fix that. Okay, and yeah, we also have lots of built-in applications. I didn't expect this to say this when we were close to 1.0. This just happened to happen during development. So we also have like a suite of things that should work nicely in our desktop. Okay, so who am I? Why am I talking to you about desktop environments at a Rust conference? My name is Victoria. I've been using Rust kind of since 1.0 alpha. I think the first time I've seen Rust, it's still green threads. Who remembers green threads? Okay, few people. I've also taught Rust at university, I think 3 times. So I hope to have this also be like a little bit of an education experience. And so I did not work on Cosmic for 8 years because Cosmic really was conceptually created 3 years ago. But I've been working since 8 years on a little project called Smithy, which you may or may not have run over on GitHub. It's a framework to write a Wayland compositor. And if those words mean nothing to you, don't worry. There'll be more explaining later. So then in 2021, I joined System 76, and that's when kind of development of the Cosmic desktop kicked off. I'm also active in the free desktop community. So maybe you've seen me around on Wayland protocols, fun discussions there. Can highly recommend it. I'm also part of the free desktop code of conduct enforcement team. So if you see anything bad happen on Wayland protocols, you can also come to me. You can find me usually everywhere as Draculix, also Matrix, also Fediverse, Mastodon. Feel free to connect, reach out. Also after the talk, I'm always happy to talk about what I'm working on. Okay, so what exactly is this talk going to be about? It's mostly about Rust, of course, and developing and how that interacted with this kind of large-scale project. First, though, I'll talk a little bit more about the background so you get a little bit of a better understanding what exactly is involved in writing a desktop environment. Then we are going into GUI development because this has been a difficult topic for Rust in the past. So I thought it would be interesting to start there. And then I'm going to end on what I know best, what I'm mostly working on, which is the compositor of the desktop environment. Again, a term I will explain at some point. Okay, so let's start a little bit with the background. What makes a desktop environment? For that, let me give you a quick demo of Cosmic. So this is what your Cosmic desktop, at least on Pop! OS, our distribution, will look like roughly when you first log in. And I can open Windows, nothing unusual here. Here's a little terminal. We have our own file manager. If I get my touchpad working. And then the kind of key feature is that on every workspace, you can do this up here, but you can also, of course, do this with shortcuts. You can swap it into tiling mode, which is when you get your windows nicely and automatically laid out, and then use shortcuts to rearrange stuff. For those of you who use an ultra-wide monitor, you probably know how insanely useful this can be. So let me also go a little bit into the customization very quickly. So what if I don't like this wallpaper, all is very space themed. Maybe I want something a little bit more neutral. Okay, now I have this nice blue and green that kind of doesn't fit the rest. We're going here. I guess we could go for a green accent color, nice. And the background would be nicer if it would be like a little bit more bluish, maybe? Yeah? Okay, that looks already better. Also, I like my square corners. I don't know, maybe you do, maybe you do not. And I also don't like the dog down there. That's horrible. Let's get it to the left side and make it hide automatically because, you don't need this all the time. So, and then there's also the launcher where we can quickly switch apps if we wanted to. And this is what Cosmic is. So everything you see here, the core applications, of course not Firefox, the whole panel, the dock, the backgrounds, the configuration, all the little applets up here. That's what kind of makes a desktop environment. And at the heart of that is the Compositor, which is the application that's actually responsible for taking all the window contents and then combining them into a single frame that you will see on your output. So that is also what's responsible for all the windowing behavior, how the tiling system works, how really the whole desktop ties together, feels, and what workflows you're using to interact with it. Okay, so a desktop like that is made up of a lot of components, and I obviously don't have time to talk about all of that. So Cosmic Comp is the Compositor. As I said, mostly an I/O multiplexer, like it takes all the input you feed into the system, your mouse, your keyboard events, and then forwards them to all the clients, so the applications that you're running. And then it takes back all the windowing contents and tries to combine that into like a somewhat coherent picture for you to look at. Then there's the panel. Actually, a quite interesting component as well, because it's also a little Wayland compositor that just runs all the little applets you've seen as separate processes, then combines them into a single panel view, and then itself submits that to the main compositor, so it's a little nested one. Then there's the launcher and also like an application library to launch stuff, and then various daemons in the background for configuration and whatever, and smaller other shell components. Like, for example, Cosmic OSD is the on-screen display. That's what shows you the little icons when you change your volume, for example. And then, of course, the actual core applications. So this is where we get like the terminal. We have a little text editor. We have our own App Store settings application you've seen. There's also like a work in progress video player, stuff like that. Okay, so when you start writing a desktop, you notice, oh wow, there's a lot of UI involved here. So we kind of need to figure out, can we write this in Rust? Do we want to write this in Rust? If we do, what kind of frameworks are already there? What do we maybe want to use? So the big question back then was, are we GUI yet? Which was much harder to answer at that point. There's a little website with the same name. I think to this day, this hasn't been updated since a couple of years and still shows, yeah, we're kind of there. I'd like to challenge that. I think we very much are at this point, but I don't think we were there 3 years ago. So in terms of toolkits, there was really a bunch of out there, and it was not a very easy choice to pick something because we had a bunch of considerations. First one is we wanted to have a native look and feel, of course. That doesn't mean really anything if you write your own desktop, right? You define what the look and feel of the desktop should be like. But given we have a bunch of very nice UX designers that wanted to have like their vision properly implemented for us, that meant, yeah, the toolkit needs to be very customizable. If it's very set in stone with like the widget it provides and how they're going to look, that's probably not going to work with us. Next thing was, of course, Rust integration. We have been using Rust at that time at System76 for a lot of components in the background. All the engineers really liked it. While it's okay and possibly even an advantage if the toolkit provides like a good C API or C++, whatever, we want to have a first-class Rust API to use that toolkit. And ideally, and that's where then things get more tricky, we want to be able to use it from non-application components, right? We want all the UI that is directly rendered by the compositor, for example, to feel like it belongs with our core applications. We want the stuff in our panel to use the same toolkit, to have the same look and feel to it. So every framework that's kind of centered around the idea that there needs to be a window also kind of is thrown out of the window at that point. And then, which is maybe not super intuitive, right? We're talking about the Linux desktop here. We want the whole thing to be cross-platform because we are, for example, also selling keyboards, and those have little configuration utilities, and we ship that as well for macOS and for Windows users. So it would be really a shame if we were to rewrite that at some point in our own toolkit and have this first-class Linux experience and then suddenly couldn't deliver the same experience on Windows and macOS anymore. And then last but not least, of course, licensing, given that all of our code is actually open source, public on GitHub, under GPL. This was luckily not a very big issue, but still something, to look into. So the first question then that came up was like, okay, are we going to use something that's like completely Rust native, or are we going to use a wrapper for some existing but probably more tested toolkit that's already out there? And for wrappers, there were a bunch of ideas, right? And of course, we could have just used GTK. There was also Qt. The Flutter is used by Canonical a lot on the Ubuntu desktop, so it certainly has proven, at least for applications, it's used there as well. But all of them kind of suffered the same problem. Qt not as much as GTK, but we try to do stuff upstream to get more components into place to be able to use the toolkit as well for shell components. And while that eventually got merged, our GTK pull request took like a year. And that is unfortunate. I don't blame them at all. Maintaining a toolkit is hard work, and not every contribution just gets the time that it might need to get through. But for us, this was kind of a deal breaker because that is not the kind of fast-paced development cycle we were going through at the time when we tried to prototype, okay, can we actually build this desktop and what do we want to do in terms of toolkit? And then there were a bunch of Rust native ones. I'm sure there were loads more, like there is every time. I feel like every year we have at least 3 new toolkits like pop out of the ground. At the time, the bigger ones were EGUI, which I actually ended up using in a Compositor for a little debug view because there an intermediate GUI library is very, very useful. But it ended up being not very performant and also not very customizable for the more typical application use case. There was Slint, or back then I think it was called 60 FPS, which seemed like a nice library, but again, did not have the kind of entry points in the Rust integration that we wanted at the time. And then there was Iced. And Iced is what we ultimately went with, but was very, very limited at the time. So a couple of the advantages that we immediately saw, it is incredibly modular, which is a very good thing if you're already thinking about, okay, can we use this toolkit in ways that it was not really necessarily intended to be used, like, for example, for shell components or even in a compositor? Because chances are you can replace those few components if the abstraction design lines are like well-defined at the right places and just get the rest of the functionality at least for free and then just re-implement the little part that doesn't work for you. For example, the windowing integration is in a separate crate. That's a good thing to know, so we can probably replace that. The rendering code was in a separate crate. All the widgets were separate. The futures integration for async code was separate. So all of that, gives like a good vibe in the beginning. It's also an Elm-like reactive toolkit. like being something that our engineers already liked and were familiar with, and reactive in as opposed to like an intermediate toolkit, what I talked about with EGUI, was also a much better fit. And it's not like using async at its core for everything, but it is designed around the idea that you can do async tasks without any issues in your GUI application, which is really nice. Writing GUI code where you can just inline do an HTTP request instead of worrying about, oh, am I running this on the main thread? Am I blocking the GUI? What kind of implications has this? Makes for a really nice developer experience. And it was completely Rust native. So like the integration aspect was most likely not going to be an issue at all. And it's also cross-platform. So that consideration was also resolved. Rust native is also another challenge, unfortunately, because that means that users of our toolkit would kind of be forced to use Rust. Of course, we could like stuff a C API on top, but given the modularity, ICE uses traits very heavily. That's not really as straightforward. So that means if you want to have something that integrates well with our desktop, you kind of have to switch your whole programming language possibly, which is for third-party apps, usually very hard and difficult sell. We don't have a good answer to this right now. We still want to experiment with other language wrappers on top. Maybe C++ interop will be good enough for many cases at some point. But yeah, so this is definitely a challenge that choosing ICE at this point provided. It also had a very, very limited widget library, which again, not the largest issue when you want to use your own styling anyway, but we had to like re-implement a bunch of stuff, layouts and everything that was not really where we needed it to be. There was absolutely no story about accessibility by the time we started using ICE. So given we want to be a good first-party Linux citizen, and also given there's a bunch of certifications our products need to go through, this was a no-go, right? We had to kind of start working on this from the start. And then the really big one was text rendering. I don't know who of all of you have suffered to look into text rendering and was forced to do that. It's not a fun topic. There's so much to get wrong and what stuff you want to get right. And the text rendering story in general across the whole native GUI ecosystem in Rust at the time was kind of not really there. So the first thing we built was Cosmic Text. Cosmic Text is a library that combines a bunch of stuff that was already there and then adds little bits and pieces where it wasn't. So for example, it uses FontDB for font loading and then implements a bunch of font fallbacks on top of that. It uses HalfRust, which is re-implementation of HalfBus for shaping. It uses Swash for rendering and then does a bunch of layout stuff, right to left text, weird sigils, a bunch of the extra emoji and whatever stuff is in Unicode. On top of that, is also no STD and like WebAssembly compatible. And these days has also a bunch of nice utility and helpers if you wanted to do text editing with it. It's gotten quite a vibrant community. I'm aware that it's used in a bunch of Rust toolkits at this point, and also powers, at least by the time of writing this talk, the Linux backend of the Z editor, for example. So that was a huge success. And I'm very glad we got that out of the way. And then the second thing we kind of started working on immediately is libcosmic, which is a library that mostly just is a huge amount of widgets that are added in a way that it fits with the Cosmic desktop. So it sits on top of ICE. It implements all the widgets we use everywhere across everything, has a bunch of utilities and then re-exports specific to if you want to implement a Cosmic application. So that gives you like the title bar, the layout, the whole window thing kind of out of the box. It has a similar help if you wanted to write an applet, for our bar, but you can really do that in any language because again, the panel is awaiting Compositor. And then of course also integrates our config system and our theming system. So all the components will look for the files on the desktop or dbus service if available and just pull the theme from there. And then look nice and in place with whatever the user set up, like I just did. So how does this look? It a little bit of code. I promise I don't have too much in this presentation. And this is also, of course, not everything, but like the main loop, if you're working with ICE, is that you have like a little initialization thing, and then you have an update and a view function. And update is where you get like events into the whole thing. It's usually a giant match statement around a message object that you define, usually in enum, and then you can return a task from the update function. And that might as well include a future that then produces another message, which at the next iteration will then get fed into your update function again. And then next to that is the view function, which just takes all the current state and produces, with nice, relatively functional syntax, like a whole widget tree of what needs to be rendered in your video. And then in the background, ICE will diff your old widget tree, the new one, and do all the necessary changes and redraw just a portion of your application that has actually changed. Okay, so the question then is obviously, is at least Cosmic GUI yet? And the resounding answer there from me at least is yes. We've done much more than we expected. We kind of expected to ship 1.0 with a bunch of like GNOME core apps for a first start. But we got our own toolkit. It's used across a bunch of applications, across all of our shell components. It's still probably very rough around like some edges. There's definitely some polish to be done here. But for us, this has worked out well. Would I say is the whole ecosystem ready for GUI applications yet? I don't know. If you're writing an application, you're probably better off not doing it Rust native at this point, but just using a well-tested toolkit and the wrapper around it. There's great wrappers for both GTK and Qt, just because you get, for example, all the accessibility stack and whatever completely for free without needing to worry about any of this. But if you find yourself in a position where, for example, for a cross-platform application or whatever, you're considering implementing all the GUI code yourself, and just using frameworks and libraries that are already there, then there's a bunch to be had there. Like, you don't need to reinvent text rendering. That's absolutely not where you have to start. There's good widget systems. There are good composable libraries. So I would say, yeah, you should, at this point in time, definitely give it a shot. So with that, let's pivot a little bit over into the compositor. I like to think, because I'm working on this most of the time, that is Cosmic's most complex component. But I think the panel, at least, is very much running up close to that title. And the toolkit is also like getting heavier and heavier each day. So question is there really like, how do you count a component? But to maybe ease that transition a little bit, let's talk a little bit about what we did to integrate then the toolkit into the compositor. That was the initial plan. Did that work out well, and how did we make it work? And I'm happy to say, like, the whole integration, like the source code that does the actual integration, not implementing additional widgets on top or like laying out the GUI that we actually have in the compositor, but just adapting between the APIs of ICE and what we already had in Cosmic, is just about 1,000 lines of code, which is kind of amazing in my opinion, because this includes, for example, like rendering in the context of the compositor with like accurate damage tracking, because we need that with proper scaling, right? You can have multiple outputs that have completely different scaling settings. And the UI could cross both of these outputs, so you kind of need to render in two sizes, different portions of the elements. And that works very well. The big issue right now is that it's all software rendering, because, Cosmic Comp needs to target old hardware. So we actually target OpenGL ES 2.1 with like 3 extensions, which is a horrible baseline. And WGPU doesn't run very well on it, and ICE recently got rid of its GL renderer. So if we don't want to maintain this on our own, I'm currently stuck with software rendering, but there's plans to hopefully fix this in the future. And also, we render so little GUI exactly like in the compositor, like a title bar, something that this really doesn't come into, like, it doesn't become like a huge issue. Also caching, of course. This also means injecting input events, though I'm cheating there a little bit because I'm right now not translating keyboard events, because I don't need to. None of the elements that I'm currently using require it. But this means like taking potentially pointer input and touch input from the compositor and feeding this into the whole widget system of Iced. And then this also includes like a bunch of custom layout requirements, right? So the second you're suddenly not bound anymore to like a fixed size window, but like a weird layout of outputs that you want your pop-up to be placed in and ideally not go over the edges, your layout requirements kind of change. And this is also where a lot of toolkits usually struggle when you try to integrate them into something like a compositor. While I'm doing like a little double layout pass right now in ICE, because I first need to figure out how big the pop-up, for example, would ideally like to be before I then figure out if I can even display it that way on the current output. It works very well, and I'm very happy that it provides that integration. And then the most annoying part by far was the async code. Because we need to adopt that to fit into Cosmic GUI's event loop. So we have this huge component sitting in the middle of the desktop that is, as I said, just an I/O multiplexer. Why the hell is that not using async? Is probably a good question to ask like for a Rust conference, right? So the event loop that we are currently using is called cloop. It's a little wordplay, of course, because it's callback based. It's very reminiscent and also uses that, of course, below of like old epoll loops you would do where you register a bunch of file descriptors. And then whenever any of them is ready for any event that you actually care about, you get a little callback telling you, oh yeah, you can do this thing now. And the things that we integrate into this run loop are, first of all, the direct rendering manager or kernel mode setting API, which is the API you get from the kernel to talk to your display controllers, so driving the outputs on your computer. Of course, the other thing we get from the kernel are input events. Those come in through the evdev system. And then there's, on the other side of the spectrum, the I/O you get from the clients, which is through the Wayland protocol. So that's what that whole word means. It's really just a protocol. It's how the client applications submit the buffers and get the input events and everything. And then lastly, but not least, we also need, of course, to be compatible with Xorg. So that's where X-Wayland as an application comes in that like feeds off the X protocol. And then we also need to integrate from the compositor side a little bit with X-Wayland through the X protocol. So that's another thing that's sitting in our event loop. Technically, we also do stuff with dbus, but I'll get to that. So, and the big reason why none of this is using async is, first of all, this is a structure that's actually not really given by Cosmic Comp, but by the library it builds on top, Smithy, which I've been working on for 8 years. And as you may recall, async was not a thing 8 years back. And the other big thing is because we have a lot of shared mutable state. So a good compositor will not take long on any of these events. So we actually expect our main loop to idle most of the time. So we don't really, except for like driving some very high bandwidth outputs or super high frequency mice, necessarily need multiple threads. We don't need to scale it in that way. But we really have like a very complex shell state that is like influenced by all of these things, right? So it could be that we have an application that is going into full screen that submits buffers in a certain format, and then we get feedback from the DRM layer on the kernel that that format is actually not suitable if we wanted to like directly scan that out to the hardware. So we need to feed back into the client that it would be nice if they would reallocate their buffers into a different format, and it's all intertwined. It's very much not something where you want to be locking all the time. It's horrible in that kind of way. And I don't think, if there is, and I just missed it the past couple of years, please tell me, there is right now a good way to do like shared mutable state in async. The options are, well, you either take the pill and just do a mutex around it. Not very nice. Or you do a local executor, cool, and then use something like a ref cell. not that cool, right? We are trying to write a safe application. We don't want the compositor to crash accidentally because we did a double borrow. That's what Rust is for. That's what the compiler is for. That's not necessarily what we want to do at runtime. So how did we get iced with like its async stuff into Kaloop? Well, luckily, Kaloop includes an async executor. So we can just create an executor and a scheduler, put one of them into the event loop, and then with the scheduler, you can just push futures into that, and they will run on the event loop, and we get a callback whenever a future returns. With like the contents. So this works really nicely with the task system that iced uses, because when I get a future out of that, I just shove it onto the event loop, and then whenever I get a message out of that, I just shove that back into iced state, which I already need to do for various other stuff like input and whatsoever, right? So ice is actually something that while slightly annoying in the beginning to figure out how to do all of this, thanks to the async integration of Kaloop, works really nicely with the event loop. Other stuff, like, for example, dbus, is not working so nicely. This is what we are currently doing for the very few services that we need to subscribe to. I just spawned another thread. I use blocking variants of the functions on there, which just in the background start async executors and everything, and then just pipe that into a channel where the other end of the pipe is hanging on our main thread in the event loop. I've talked to Sishan, who maintains Zebus, about this. I don't blame Zebus at all. In fact, we are still doing this because Zebus is such a nice API to work with compared to what we did before with libdbus. But libdbus gave me a file descriptor. So given that this is kind of the state of the ecosystem, what are we planning to do here to hopefully fix this in the future? Can we get the compositor async? I hope so, but I'm waiting on a few things. I'm waiting on the tracking issue for context X or anything comparable so that we can actually have mutable state that is passed around between all the futures. I'm waiting for us to finally have like a Vulkan renderer, because then I can try to like outsource all the horrible GL stuff into like a separate thread or abstract it in another way, because I can't even rely at this point on us having like GPU fences. So there are cases with synchronization between multiple GPUs where I'm forced to call into the driver for a blocking wait call and just wait for it to return to me, which is amazing when you try to like run an async event loop, right? And totally not a performance disaster already. And then, of course, I hope that the ecosystem adopts more of the stuff so that I don't have to re-implement everything that I did for Kaloop just in async now, and that the whole transition will be a little bit more smoothly and more seamless. So my hope is eventually we hopefully have the compositor run async. The other question is, do I have to? Do we need to do this? And I don't think it's all or nothing. So for one thing, I'm hoping that at some point I can just switch at least over the main thread that deals with a bunch of the client messages and other stuff, and then maybe have other things like rendering for our outputs just put out into other threads which don't need to run an async executor, and have nice cooperation between all of these things that way. Also, I'm not sure if I ever will have everything async, because sometimes we have very high scheduling requirements, right? If we want to render for an output, especially for ones that are not super high of a refresh rate, we want to do the rendering as late as possible so that the user sees the latest window contents it could have possibly seen on that refresh cycle of the output. So you need to measure, okay, what was the average time of the last couple of frames, and then make sure to really hit that time frame. And if you don't, you miss a V-blank. So you get stuttering and really bad user experience at that point. And I don't know, I have not looked too much into this, how much especially single-threaded executors are equipped to handle with this. So it might as very well make more sense to put these things on separate threads and then just have like the general backbone of the compositor in the main thread use async. So no, right now we absolutely don't have to. Like the hack, for example, we use with ZBus works perfectly fine. But I'm fearing this will get worse, right? ZBus is just the first of possibly many examples of things in the ecosystem that just start to fully embrace async and go away with all the primitives that are below that make up async. So to everybody who maintains anything that has to do with I/O, std or sfd exists. Please just implement it. I know that I can shoot myself in the foot there, but it makes my life so much easier if I don't have to fork your library or start from scratch because you're not exposing your primitives. So this is kind of the call out. If you have any other ideas or better ideas to solve the situation and want to talk to me about it, I'm more than happy to. Thank you so much. I believe we have some time for questions. I'm not sure. If not, I'm subscribed to the Discord channel for this talk. I'm happy to answer questions there. You can also find me on the conference. Happy to talk to you about there, and I'm also happy to info dump about anything else in Cosmic. This is just the topic I selected for this talk. Hope you had a good time.
Thank you.